Hi, and welcome to my video. This video is on the properties of a parabola, but it's a new unit on solving quadratic equations of different forms. So this first video is dealing with the properties of a parabola, which is a quadratic. And the first property is the vertex of a parabola. The vertex is a point on the parabola where its curve changes slope. A is a vertex. And notice, if A is the vertex, then the left-hand side goes up like that. And if I draw a line through this curve, the line has a negative slope because it's up to the left or it goes down to the right. And if I draw the curve on the right side, then it has if I draw a line through the curve, then it has a positive slope because it's up to the right. Notice we have B. This, just forgot to mention that this parabola is opening upward and this parabola is opening downward. So this parabola has a vertex of B and the left hand side is going like that. And we draw a line through 2 points on this curve. This line has a positive slope, and we draw the parabola on the right side, and we draw a line through that curve, then this has a negative slope because it's up to the left or it's down to the right. And this parabola has this shape right here, and it's opening upward. The vertex is right here, and this vertex is -2, 1. And we have a parabola here that's opening downward, and the curve is changing from a positive slope to a negative slope. So there's the vertex, and the vertex is -1, 3. And just get back to this one. This parabola is opening upward. So on this side, the curve has a positive slope because it's up to the right. And on this side, the curve has a negative slope because it's up to the left or it could be down to the right. And the vertex of this parabola is right here. This vertex is x is 2 and y is 0. And you can see that the right side has a positive slope because it's up to the right, and the left side has a negative slope because it's up to the left. And this final one, the vertex is right on the y-axis, 1, 2, 3, 4. So this vertex is 4, 0. And this is the vertex. The right side is going down, and the left side is going down, but this side right here, if I draw a line, has a negative slope because it's up to the left, and this side here has a positive slope because it's up to the right. So the vertex of a parabola is the peak point on the curve. And the curve is made up of a positive and a negative slope. Another property of a parabola is what we call the axis of symmetry. A for axis, O for off, and S for symmetry. The axis of symmetry is a vertical. It's a vertical line through the vertex of a parabola. So if this is the vertex of a parabola right here, is the peak point. So the vertex is 3, -2. So the axis of symmetry is a broken line because it's not a part of the graph. It's a broken line that's perpendicular to the x-axis, parallel to y, and the axis of symmetry is x equals 3. And the axis of symmetry splits the parabola into 2 equal parts. And here we have a vertex, and the vertex right here, x is 1 and y is 3. And the axis of symmetry is a straight line right straight down through, and the axis of symmetry is x equals 1. We call it AOS, axis of symmetry. AOX, axis of symmetry is x equals 1. And the vertex of this parabola is right here, is the peak point. And this vertex is x is -2, y is 1. And the axis of symmetry is a vertical line straight down through, cutting the x-axis at -2, axis of symmetry. And in the fourth one, the axis of symmetry Let's get the vertex first. The vertex is right here at the peak point where the graph changes from a negative slope and a positive slope. So the vertex is x is -3, y is 0. So the axis of symmetry is the vertical line down through the vertex, and the axis of symmetry is x equals -3. The axis of symmetry splits the parabola into two symmetrical parts. The left side and the right side are reflections of each other. Let's take the basic parabola y equals x squared. The table of values is 2, 1, 0, -1, -2. We square the x. 2 squared is 4, 1 squared is 1, 0 squared is 0, and -1 squared is 1. -2 squared is 4. And the vertex on the basic parabola is 0, 0. And you notice this is in the middle. 0 is in the middle because the 1 is on each side and the 4 is on each side. If we graph those ordered pairs, 2 is a 4, 1 is 1, 0 is 0, -1, 1, -2, 4. So there's the parabola, and you can see that the vertex is 0, 0, symmetrical on each side. So the axis of symmetry for the basic parabola is x equals 0. It's a vertical line down through the vertex at 0, 0. And the axis of, as we can see, we have the axis of symmetry is down. We have the left side going up like that, and we have the right side going up like that. And the axis of symmetry is x equals 0, splitting the parabola into a left side, right side, with the same ordered pairs on each side, except the y values are the same. And in this parabola, we have a vertex of x is 3, y is 2. The vertex is 3, 2, and the axis of symmetry is x equals 3. It's a vertical line drawn. It's a vertical line drawn through the vertex of the 2, 3, so it has the same x coordinate of 3, x equals 3. Axis of symmetry, again, it's a vertical line through the x-intercept, and it's x equals. And the equation of a vertical line is x equals. Another property of a parabola is the y-intercept. The y-intercept of any graph has the x-coordinate of 0. So a y-intercept has an x-coordinate of 0, 0, comma y. And remember that a y-intercept intersects or cuts, it cuts the y-axis. So the y-intercept lies on the y-axis. And as a line, we have a line drawn here, and notice that this line, the linear, is cutting the y-axis at x is 0, y is 1. So y-intercept is cutting the y-axis at 0, 1, so the x-coordinate is 0. And this is a line also cutting the y-axis right here. This y-intercept right here is x is 0 and y is -2. So it's cutting the y-axis at -2. But notice the x-coordinate is 0. Y-intercept, x-coordinate is 0 because it's cutting the y-axis. A parabola has a y-intercept also, but the parabola will only cut the y-axis at one point. So this y-intercept right here is x is 0, y is 2. Notice this parabola is opening upward. This parabola is opening downward. Its vertex, vertex is right here opening downward. So its y-intercept is x is 0 and y is -1. So a parabola has only one y-intercept, and that's where it cuts the y-axis, and the x-coordinate is always 0. State the coordinates of the y-intercept of each parabola. The y-intercept of this one right here, cutting the y-axis, the y-intercept is x is 0, y is -1. Notice x is 0, y is -1. And this parabola has a vertex right here, but we can name the vertex, but the y-intercept is, that's what I'm more concerned with, the vertex is here, but the y-intercept is right here, so the y-intercept is 0, 3. That's where it cuts the y-axis. So every parabola has, notice the parabola is y equals x squared in that form, so it has one y-intercept cutting the y-axis. Let's graph each parabola. Opens up with a vertex of 2, negative 3, with a y-intercept of 2. Got a vertex of plus 2, and y is negative 3. X is 2, and y is negative 3. That's the vertex right there. It got a y-intercept of 2. So the y-intercept of 2, remember the y-intercept cuts the y-axis, so the x coordinate is 0, and the y is 2. So the y-intercept is 2 is right there. So we have to draw a parabola that leaves the vertex, goes up to the y-intercept. So there it is, going up like that. And it's on the other side, so that's 2 units over. So we go 2 units over here, and we pick up the same value of y. Remember, it's symmetrical on each side. So what happens? If you go 2 units to the left and get a 2, if you go 2 units to the right, you get a 2. So that's how we draw the parabola with vertex and the y-intercept. B opens down with a y-intercept of 1. So the parabola has a y-intercept of 1, which is right there, and it opens down. So if it has a y-intercept of 1 and opens down, well, that means we can put, the vertex has to be somewhere up here if it opens down. So I could draw, put the vertex right here, and I could draw like this. Or I could put the vertex, it has to stay above this line of 1. So I could put the vertex right here and let it go down. As long as it's symmetrical. So as long as I got a y-intercept of 1, but the vertex has to be above. It has to be above this, because how can you have the vertex down here? If you had a vertex here, it would have to go up to go to that intercept. So all the vertices has to be above 1. But it could go anywhere above 1. Anywhere you want. It could go like this and over. As long as the vertex is above the 1. Okay. And also we have x-intercepts of a parabola. The x-intercept of a graph has the y-coordinate of 0. So x-intercepts have a y-coordinate of 0 because they cut the x-intercepts, cut the x-axis, cuts the x-axis. And the x-intercepts, when you say cut, the x-intercepts lie on the x-axis. So we have a line. Notice this is the x-intercept right here. This line is cutting the x-axis here. So the x-intercept, x is 2, y is 0. This line right here, which has a negative slope. This line has a positive slope because it's going up to the right. This line has a negative slope because it's going up to the left, or it's going down to the right. So the x-intercept on this line is right here, and we mark another point just to make sure. We make that a 3, so you know that that's a 1, that's a 2, and that's a 3. So the x-intercept is 1, 0. Notice that with an x-intercept, the y-coordinate is 0. So every x-intercept has a value of x, but the y-coordinate is 0. And a parabola, well, let's go through scenarios of a parabola. A parabola can have 2 x-intercepts cutting it at 2 spots. It can have 1 x-intercept cutting it at 1 point, or it can have no x-intercept. Let's explain. A parabola, notice this parabola got a vertex right here and is opening upward, but it's cutting the x-axis at -1. Notice it's cutting the x-axis at -1, 0, and it's also cutting the x-axis at 2, 0. And right here, this parabola cuts the x-axis twice. It cuts it at -1, 0. It also cuts it at 4, 0. Again, x-intercepts have y coordinates of 0. And this parabola here cuts the x-axis at only one point right there. So that x-intercept is 2, 0. There's only one x-intercept. And notice that x-intercept right here is the vertex. This one is going up, and this one is going down. And the x-intercept here is 2, -2, 0. And again, it only has one x-intercept. It's not cutting through. It's going up towards here and bouncing off. Notice it's bouncing off. Notice that this x-intercept is coming down, hits the axis, and bounces off. Whereas here, the x-intercept, it goes on through, loops, and comes down again. And the same here. It goes on through, loops, and goes up again. And this parabola, notice this parabola is not cutting the x-axis. It has a y-intercept, but it has no x-intercept. Not cutting the x-axis. It's going upward. All the y values are positive on this graph. And on this one, there's no x-intercept, because the parabola is not cutting through the x-axis. No y-intercept. Sorry, no x-intercept. It's not cutting through the x-axis. State the x-intercepts of each. We have a parabola. The x-intercept right here is -2, so it's a -2, 0. The x-intercept right here is 2, 0. And on this parabola, the x-intercept here is 0 right there, so that's 0, 0. And the x-intercept here is 4, so that's 4, 0. Again, when you have x-intercept, the y coordinates are 0. And in this one, we have an x-intercept right there, which is the vertex. So we only have one x-intercept, so it's 1, 0. Because when you have one x-intercept, it's bouncing off, and you have the vertex at that point. And in D, the parabola vertex is here, is not cutting through the x-axis. It has a y-intercept right there, but it has no x-intercept because it's not cutting through the x-axis. And notice an x-intercept, the y value is 0. A y-intercept, the x value is 0. Another property of the parabola, the x-coordinate vertex is the average of the x-coordinates of the x-intercepts. In other words, the x-coordinate of the vertex is in between the two x-intercepts. So if I have a parabola cutting the x-axis at A and B, then the x-coordinate of the vertex is in the middle, halfway between these two. So if A is x1, 0, and B is x2, 0, then the x-coordinate of the vertex is, add them up, x1 plus x2 over 2. It's in the middle. So when we say average, we mean it's the middle. It's in the middle, halfway between. State the x-coordinate of the vertex of this parabola. So if you have an x-intercept here of, 1, that's a 1, and this x-intercept here is 2, 3, 4, 5. So if we take the 1 and add on the 5 and divide by 2, you get 6 over 2, you get a 3. So the x-coordinate of the vertex is a 3, and we don't know what the y is. That would depend, whatever this is right across from here. But the x-coordinate of the vertex is 3. It's the average of adding up the two x-coordinates because it's symmetrical. Remember, the axis of symmetry is down through the middle. The axis of symmetry is x equals 3. So the x-coordinate of the vertex is 3, halfway between these two. And again, this is a 3. 2 to the left is 1. 2 to the right is 5. 2 above, 2 below, 1 and 5. And if the x-intercepts are -2 and 4, if we add them up, divide by 2, 2 over 2 is 1. And if you draw a grid. The x-intercepts are -2 right there and 4 right there. So what's halfway between those two? Well, let's count 1, 2, 3, 4, 5, 6 units between here. 3 is in the middle. So 3 is in the middle. So there it is right there. So the vertex, whatever, you could have the vertex, you could have the parabola doing this with the vertex right here. So that would be a 1, comma, whatever the y value is. Or you could have it doing this, like this. Oops, let me draw that. You could have it open upward, and the vertex would be right here. The vertex would be 1, comma, whatever this y value is here. So the x-coordinate of the vertex is halfway between the x-intercepts of your graph. State the coordinates of the other x-intercept of the parabola. If you have a vertex, let's see, we have a vertex of -1, 2. So -1, 2 is right there. If that's the vertex of your parabola, and 3, 0 lies on the parabola. Well, 3, 0 is 3, 0 is this point right here, and 3, 0 is the x-intercept. So that means that between the x-coordinate of your vertex right here, that's a -1. So if that's the vertex right here, then the x-coordinate of your vertex is -1. So that means this intercept is 4 units to the right from a -1. So when we go 4 units to the left, we get a -5. So the other x-intercept is the -5, 0. And check. If we take 3 and add on -5 and divide by 2, we get -2 over 2, which is -1, which is the x-coordinate vertex. B, we have, let's see what we have here. We have a -3 x-intercept. So that's a -3, 0. So -3 is an x-intercept. Okay. And we have an axis of symmetry of x equals -1. Axis of symmetry of x equals -1. The axis of symmetry is straight down through like that, and that's a -1. But the vertex could be up here or down here, it makes no difference. So this is one x-intercept at -3, and the axis of symmetry is -1, which is in the middle. So a -1 is in the middle of a -3, and if we went 2 to the left, we have to go 2 to the right, 1, 2. So we hit there. So the other x-intercept would be 1, 0. So 1, 0 is the other x, is the x-intercept, the other one. And again, remember, the x-coordinate of vertex, or the axis of symmetry, is in the middle between the two x-intercepts. So that's some properties that we did a little review on. That's going to help us do the videos as in this section. Thank you. If you like my video, click the like button, the subscribe button, and notification bell. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And that's the content that's on my YouTube channel called Math Fully Explained. Thank you very much. Bye-bye.